The next topic is multiplication of two determinants of the same order. Multiplication of determinants of same order. We'll take example of a 3 cross 3 sized determinant or the third order determinant. Let's assume that we have the first determinant denoted by A1, C1, A2, B2, C2, B3, B3, C3. This is the first determinant. Anyway, we can find the determinant and then take a product. But now we are using a method called method of multiplication, which is row by row multiplication. So delta 2 is the second determinant denoted by alpha 1, beta 1, alpha 2, beta 2, gamma 2, alpha 3, beta 3, gamma 3. Okay, so these are the two determinants which we want to multiply. So the multiplication happens in this way. So if I want to calculate the delta, which is equal to the delta 1 into delta 2, without simplifying both the determinants, we can perform the multiplication. That is, I have to take a determinant of A1 alpha 1 plus B1 into beta 1 plus C1 into gamma. Then A1 into the second row, this is alpha 2 plus B1 into beta 2 plus C1 into gamma 2. And the third value in the first row will be A1 alpha 3 plus B1 beta 3 plus C1. Right, this is the first row. Like that, we need to write three different rows. Second one, this is A2 alpha 1 plus B2 beta 1 plus C2 to gamma. Then A2 alpha 2 B2 into beta 2 C2 into 2. Then A2 alpha 3 B2 beta 3 C2 into 3. A3 into alpha 1 plus B3 into beta 1 C3 into gamma 1 A3 alpha 2 B3 beta 2 C3 2 A3 alpha 3 B3 beta 3 C3 gamma 3. We need to simplify this determinant value. Then we need to apply row or the column, right? Whatever operations we can perform, we have to do that. And then we should simplify this determinant to get the total product. All right, now, all right, let's try to solve a problem. So solve for delta. Delta is equal to, this is minus 2, 3, 2, 3, 4, minus 4 into minus 2, 1, 3, 3 minus 2, 1, 2, 1, minus 2. So as per the above said equation, we'll multiply. This method is called as a method of row by row multiplication. Okay, so I'll multiply. So the first number 1 into minus 2 is minus 2 plus 2 plus 9. Next, first row into the second row of the second matrix. So this is 3 into 1, 2 into minus 2 plus 3. Then we have 2 plus 2 minus 6. Similarly, second row into the first row first, then second row, then third. Okay, so minus 2 into minus 2 is plus 4 plus 3 plus 6. Then this is minus 2 into 3, so minus 6. 3 into minus 2 is also minus 6 plus 2. Then we have minus 4 plus 3 minus 4. Later, minus 6 plus 4 minus 12. 9 minus 8 minus 4, 6 plus 4 plus 8. We need to find the determinant of this. So let us try to simplify and write that determinant here. So this is 9, 2 minus 2, 13 minus 10 minus 5 minus 14 minus 3, 18. So we can perform any operation we want, right? And we have to simplify this to get a single value. Okay, let us try to apply the row and column operations to this first. So I want to perform, let us say, okay, let's perform this. C1 is equal to C1 plus C3, and say C2 equals to C2 plus C3. So this means the determinant, column 1 remains same, 9, 13 minus 14 remains, sorry, C1 changes. C1 and C2 change, C3 as it is. So let's try to update. So C1 is equal to C1 plus C3. Let's add. So 9 minus 2 is 7. Then 13 minus 5 should be 8. Minus 14 plus 18 is 4. Okay, all right. Then C2 and this. So 2 minus 2, 0. Minus 10 minus 5 is minus 15. Minus 3 plus 18 is plus 15. Right? C3 as it is, minus 2, minus 5, and 18. Okay, let me try if I can get a 0 somewhere. I can get a 0 here. Okay, so I want to perform row 2 is equal to row 2 plus row number 3. So that gives row 1 unchanged. So 7, 0, minus 2. Row 2 plus row 3. So this is 12, minus 15 plus 15, 0, minus 5 plus 18 is 13. Row 3 as it is. So this is 4, 15, 18. Okay, this determinant. Now we see we can expand. The idea is that instead of simplifying this with respect to 7 and 7, 0 and 2, I prefer doing it with respect to the third column. That is because two of them will be 0, right? Two of the entries will become 0. That means when I take this, it's a 0 because 0 into something into this, that's also 0. Also, when I try to take with respect to this, it's also 0 because 7 into 0, 12 into 0. So I don't have to solve two of the determinants, only one of them. So that is only the 15, right? So if you take this, this is positive, this is negative, this is positive. Like we do for the, if we expand the determinant with respect to the first term. Okay, so that's why. So this is equal to minus 15 into, solve the determinant. So determinant should be 7 minus 2, 12, 13. Okay, so this is minus 15 into 13, 91. Minus of minus is plus 24. So minus 15 into 5, 1, 5. Okay, please find this answer. Minus 1725. All right. Okay. Next question. So solve using the method of multiplication. All right. So we want to solve delta is equal to 1 by 3, 2 by 7, minus 8 by 17, root 3, minus 1 by root 2, 7, minus 13, 11 by 16, 0, into 7 by 4, minus 9 by 7, 13 by root 2, 3 by 4, minus 1 by 6, 8 by 19, 2 by 11, root 3, minus 1 by root 3. So when we solve, we get answer equal to 5.035 product of the determinants. Okay, let's move further. The next concept is called as the Cramer's rule. This is used to solve the system of linear equations. So first we'll apply this Cramer's rules to solve the system of linear equations in two variables. Okay, so let us consider the equations like this. We have a1 x plus b1 y plus c1 equals to 0, a2x plus b2y plus c2 equals to 0. There is a condition that the a1 divided by a2 should not be equal to b1 by b2. If at all they are equal, right, then you have infinite solutions. Okay, depending upon whether c1 and c2 are also same, right? Depending on that, we have n number of solutions coming up in picture. Either the system becomes non-consistent or dependent equations. One is dependent on another. It becomes that. That's why we avoid these conditions. A1 by A2 ratio should not be same as the B1 divided by B2, right? That's what we study in the linear equations. Okay, right. Now, how to solve this? According to the Cramer's rule, this is the equation, that is x divided by the determinant b1, c1, b2, c2, right? So you see that when you consider x, you remove that from this, only write the coefficient b1, c1, b2, c2 over here to get that determinant. Okay, so that's the first equation that we are going to write. This should be equal to, according to this is equal to the y divided by, when I write y, I eliminate the coefficients of y and write the remaining. Okay, so this is, it's minus y divided by, or you can take the determinant, the minus to the determinant. Okay, so I can try to write in this way. So this is minus of the same thing, that is a1 c1 a2 c2. This is equal to 1 divided by, right, because there is no x or y term, so powers are assumed to be 0, x to the 0, y to the 0. That is 1, value is 1 divided by. This is determinant of a1, b1, a2, b2. This determinant is what we need to consider. So this implies if you want to calculate x, right, you equate these two. Simply equate these two. Take that, keep x on one side, determinant should be moved to the other side. Okay, that's all. So this is determinant of b1 c1 b2 c2 divided by determinant a1 b1 a2 b2. Similarly, y is equal to determinant, it's negative a1 c1 a2 c2 divided by, this is a1 b1 a2 b2. Now let's try to simplify this, because keeping that in the determinant mode may not be so good, right? So that means we can simplify. Determinant is, this is b1 c2 minus b2 c1 divided by a1 b2 minus a2 b1. That is equation for x. Similarly, the equation of y can be calculated. So this is minus of a1 c2 minus a2 c1 divided by, denominator is same, a1 b2 minus a2 b1. Okay, so these equations we can remember and we can apply as and when we require to solve a solve system of linear equations with the two variables. Let's go for an example. So solve x plus y is equal to 2, x minus 1 equal to 6. So the a1 b1, so I have to convert this into the required format first, right? So this is x plus y minus 2 equal to 0, then x minus y minus 6 equal to 0. So I can write the a1 b1 c1. So a1 is 1, b1 is 1, c1 is minus 2 from the first. Then I can write a2 is 1, b2 is minus 1, c2 is minus 6. a1 b1 c1 a2 b2 c2. So because original equations we considered here are like this. So in this mode, whatever coefficients we get, they are a1 b1 c1 a2 b2 c2. So for that reason we have. Now I just have to check a1 by a2 1 by 1 is not equal to 1 divided by minus 1. So that condition is satisfied, so I can proceed. So simply you can calculate x is equal to, this is b1 into c2 minus 6 minus b2 into c1 divided by a1 into b2, that is 1 into minus 1, minus a2 into A2 into B1. So that is 1. Okay, so that's the equation. So this is 1 into minus 6 is minus 6. This is minus 2 divided by minus 2. So this is minus 8 by minus 2. So we have A equal to 4. So once you have this, you don't have to solve the other one. Directly, simply you can apply the other equation to get this, because we know that the x plus y is equal to 2 given. This means what should be the value of y? So y is equal to 2 minus x. So 2 minus 4. So that is equal to minus 2. Okay, this is the required answer. Okay. Next question. 2x minus y is equal to 3. X plus 3y is minus 2. Solve using Cramer's rule. So when we solve this, we get the following answer. X equal to 1 and y equal to minus 1. One more. Solve. X plus y equal to 4. 3x minus 2y is 9. X equal to 17 by 5, which is 3.4. Okay, then y is equal to 3 by 5, which is 0.6. Okay, this is the Cramer's rule applied for a 2 cross 2, or the system of linear equations with the two variables. Let's move further. The Cramer's rule, now we try to apply, right, for a system of linear equations in 3 variables. Okay, so let us try to write the equations in the following fashion. A1x plus b1y plus c1 z, 3 variables. So this will be written as equal to, say, d1, a2x plus b2y, c2z equal to, say, d2, then this is a3x plus b3y c3z equal to, say, d3. Now, so what we do, initially we find the overall determinant of the equation without the right hand side. That is d1, d2, d3 should not be written. Just calculate the normal determinant, that is a1, b1, c1, a2, b2, c2, a3, b3, c3. Right. Then calculate the, replace every column by d1, d2, d3 to calculate the delta 1, delta 2, delta 3. So first, when we calculate delta 1, remove the a1, a2, a3 and replace it with the d1, d2 and d3. That means I'm supposed to write like this. So determinant of d1, d2, d3 remaining as it is, b1, b2, b3, c1, c2, c3. Calculate determinant. Okay, then let's go for another determinant, delta 2. So replace the second column remaining as it is. So a1, a2, a3 as it is. replace the second column by the right hand side, that is D1, D3. Third column as it is C1, C2, C3. Third determinant delta 3. Now the third column has to be replaced. So first A1, A2, A3 as it is, B1, B2, B3 as it is. So this is D1, D2, D3. So once we have all of them, we can calculate the value of x. X is nothing but delta 1 by delta. Y value can be calculated as delta 2 by delta. Z value can be written as this is delta 3 by delta. So should calculate and keep ready all the four determinants, and then we will apply to get the final answer. Okay. Now let us try to solve a problem. Solve the following equations. This is x plus y plus z equals to 9, 2x plus 5y plus 7z equals to 52, 2x plus y minus z equals to 0. Alright, so first let us calculate the required delta. This is equal to coefficients 1, 1, 2, 5, 7, 2, 1, minus 1. Find its determinant. So solution of the delta comes to be 4. Now what we do, we calculate the delta 1 by replacing the first column of this above determinant by the right hand side, that is 9, 52 and 0. So that means this is determinant 9, 52, 0. Then remaining 1, 5, 1, 7, minus 1 as it is to calculate the value of delta 1. So this also comes as 4. Let's calculate the delta 2 now. So for calculation of delta 2, keep the first one as it is, 1, 2, 2. Second column replace 9, 52, 0. Third column as it is, 1, 7, minus 1. So this comes to be equal to, let's go ahead, calculate a delta 3 which is equal to replacing the third column. Okay, so this is 1, 2, 2, 1, 5, 1, 9, 52, and 0. This is equal to minus 20. So now let's calculate the unknowns. X is equal to delta 1 by delta. So delta 1, we can see it is minus 4, and delta also came as minus 4. So this is x equal to 1. Then y is equal to delta 2 by delta. So delta 2 is minus 12, delta is minus 4. So this is 3. And the z value is equal to delta 3 by delta. So delta 3 is minus 20 divided by minus 4. So that is equal to 5. So this is how we can solve this system of linear equations with the 3 unknowns or degree 3 by using the Cramer's rule.